Hello friends, welcome to my channel Eccentric Learning. I hope you have gone through the first part of algebra in the last video where I have covered some of the algebraic formulas and concepts related to numbers which are in the form of a raised to power n plus minus b raised to power n. In case if you haven't gone through that video till now, the link has been given in the description box. Please go through it. Also, if you like my videos, then do subscribe my channel and also share with your friends. In today's video, we'll be seeing some problems based on the formulas and concepts that we have seen in the last video. So let us start with today's video. Let us start with this question today. If x minus 1 by x is equal to 6, then find the value of x cube minus 1 by x cube. Well, before seeing the solution of every question, I would suggest you to do the questions from your end first and then to check the solution. So we have been given x minus 1 by x equal to 6 and we need to find the value of x cube minus 1 by x cube. Well, we know that a minus b whole cube can be written as a cube minus 3ab a minus b minus b cube. So if we simply do cube on both sides, in that case, this would be x minus 1 by x whole cube and this would be 6 cube. Now we can simply use the formula for a minus b whole cube. So in that case, x minus 1 by x whole cube would be x cube minus 1 by x cube minus 3ab. So here a is x and b is 1 by x times of a minus b, which would be x minus 1 by x. And this is equal to 6 cube, which would be 216. So if we simplify this, this would be x cube minus 1 by x cube. We can cancel this x and x and we can replace this x minus 1 by x with 6. So this would be minus 3 times of 1 times of 6 and this would be equal to 216. So from here, x cube minus 1 by x cube would be simply 216 plus 18, which would be 234. So the value of x cube minus 1 by x cube would be simply 234. Now let us see this question. X plus y upon z is equal to minus 1, then find the value of this expression. So here we have been given as x plus y upon z to be minus 1, which can be written as x plus y is equal to minus z, which would be x plus y plus z is equal to 0. So we have been given this condition that x plus y plus z is equal to 0 and we need to find the value of this expression. Now this expression can be simplified and can be written as x cube plus y cube plus z cube upon xyz simply by taking the LCM of the denominator. And from the last video, we have seen one formula that if a plus b plus c is equal to 0, then a cube plus b cube plus c cube can be written as 3 of abc. So here x plus y plus z is 0. So x cube plus y cube plus z cube can be written as 3 times of x, y, z. And this is divided by x, y, z. So this x, y, z and x, y, z can be cancelled from the numerator and denominator. So this would be simply 3. So you can see by using this formula, we have got the answer so easily. So that's why it becomes very important to remember some of the formulas. Now let us see this question. If x is equal to 3 upon root of 7 minus 4 root 3, then find the value of this cubic polynomial. So x is equal to 3 upon root of 7 minus 4 root 3 and we need to find the value of this expression. Well, if you look here, we have a surd inside a square root. So first let us try to find the square root of this surd. So when we find the square root of 7 minus 4 root 3, this would be coming as 2 minus root 3. Well, how to find the square root of a surd, I have already covered in the indices and surd chapter. So in case if you're unable to get how we are finding the square root as 2 minus root 3, in that case, I would suggest you to go through the indices and Surds chapter first and then to come back to this video, the link of which I have given above and also in the description box. So x would be 3 upon 2 minus root 3. Also, we have learned one thing in the indices and Surds chapter, that whenever we have an irrational number in the denominator, the first thing that we need to do is rationalization. So if we do the rationalization here, in that case, this would be 3 times of 2 plus root 3. And in the denominator, we'd be having 2 minus root 3 times of 2 plus root 3, which would be a plus b, a minus b form. So that would give us a square minus b square. So that is 2 square minus root 3 square. So this would be simply 3 times of 2 plus root 3, and in the denominator we'd be having 4 minus 3, which would be 1. So the value of x is simply 6 plus 3 root 3. Now we need to find the value of this cubic polynomial. We know that a minus b whole cube is given by a cube minus 3a square b plus 3ab square minus b cube. So let us try to restructure this cubic polynomial into this form. So this can be written as x cube minus 3a square b. So let's assume a here is x. So this is x square into b. So let's assume b to be 6 plus 3ab square. So we have 3a here is x and b square would be 6 square minus b cube. So this has to be 6 cube. Now we need to adjust some of the terms. So here we have minus 18x square. So here we have minus 18x square. So that is okay. And here this would be 6 square into 3. So that is 36 into 3, which would be 108x. But here we have 81x. So to balance this out, we need to subtract minus 27x, because 108x minus 27x would be giving us 81x. And here we have minus 6 cube. So that is we have minus 216, but here we have minus 36. So to balance this out, we need to add plus 180, because minus 216 plus 180 would give us minus 36. Now this can be written as in the formula as x minus 6 whole cube minus 27x plus 180. Now from here we know that x is equal to 6 plus 3 root 3. So x minus 6 can be written as 3 root 3. So let us use the value of x minus 6 as 3 root 3 here. So in that case, this would be 3 root 3 whole cube, and this would be minus 27. And let us replace the value of x as 6 plus 3 root 3. And this would be plus 180. So now we have got rid of the variable x in this expression. So if we simplify this, we'd be getting the value as 18. So the value of this expression would be 18 when x is 3 upon root of 7 minus 4 root 3. Now let us say this question. How many pairs of non-negative integers mn are there such that 3m plus 2n is equal to mn? So m and n are non-negative integers. So that means m and n can take a value 0 or any positive integer. Well, the best way to find the number of pairs in such kind of questions is to restructure this equation into factors. And it can be done simply by taking everything to one side. So if we take 3m plus 2n to the right hand side, in that case, this would be mn minus 3m minus 2n equal to 0. Now to find the factors, we need to add the product of the coefficient of m and n. In this case, the product is 6. So we need to add 6 to both sides. Now from the first two term, we can take m common. So we'd be left with n minus 3 and from the third and the fourth term, we can take -2 common and we'd be left with n minus 3 again. And this is 6. Now again, we can take n minus 3 common, so we'd be left with m, and this would be -2. So m minus 2 times of n minus 3 would be 6. So now we need to find pairs of m and n such that m minus 2 times of n minus 3 would be giving us 6. Since m and n are integers, so m minus 2 and n minus 3 will also be integer, and the product of these two integers would be giving us 6. And the possible ways would be m minus 2 can be 1, n minus 3 can be 6, or m minus 2 can be 6, n minus 3 can be 1, or m minus 2 can be 2, n minus 3 can be 3, or m minus 2 can be 3 and n minus 3 can be 2. Now, when m minus 2 is 1 and n minus 3 is 6, in that case, the pair mn would be 3 and 9. In a similar way, when m minus 2 is 6, n minus 3 is 1, the pair mn would be 8 and 4. And when this is 2 and n minus 3 is 3, in that case, this pair mn would be 4 and 6. And when m minus 2 is 3 and n minus 3 is 2, in that case, the pair mn would be simply 5 and 5. So when we are considering the positive factors of 6, then there are 4 pairs of m and n such that 3m plus 2n is equal to mn. But we can consider the negative factors of 6 as well. For example, m minus 2 can be -1, n minus 3 can be -6, or m minus 2 can be -6, n minus 3 can be -1, or m minus 2 can be -2, n minus 3 can be -3, or m minus 2 can be -3 and n minus 3 can be -2. But except for the third case, all the other 3 cases won't be possible, because in that case, at least one of m or n would be negative. But when m minus 2 is 2, in that case, m would be 0, and n minus 3 is -3, in that case, n would be 0, which is a possible case because we need to find pairs of non-negative integers. So one mn pair will also be 0, 0. So altogether, there would be 5 pairs of non-negative integers of mn such that 3m plus 2n is equal to mn. So to solve such kind of question, we can simply convert the equation into factors and then we can find the required number of pairs. Now, let us see this question. Which of the following are factors of p raised to power 36 minus q raised to power 36? Well, before answering this, let us recall what we have learned in the last video. A raised to power n minus b raised to power n always has a factor of a minus b, irrespective n is even or odd. And it has a factor of a plus b only when n is even. So using this concept, we can say that a and e will be the factor of p raised to power 36 minus q raised to power 36. As p raised to power 36 minus q raised to power 36 can be written as p raised to power 12 to the power 3 minus q raised to power 12 to the power 3. And this is of the form of a raised to power n minus b raised to power n. So this will have a factor of a minus b, which is p raised to power 12 minus q raised to power 12. In a similar way, it will have a factor of p raised to power 6 minus q raised to power 6. Now we know a raised to power n minus b raised to power n will have a factor of a plus b only when the power is even. So p raised to power 9 plus q raised to power 9 will be one of the factors of p raised to power 36 minus q raised to power 36, as this can be written as p raised to power 9 to the power 4 minus q raised to power 9 to the power 4. So here we have even power. So p raised to power 9 plus q raised to power 9 would be one of the factor for p raised to power 36 minus q raised to power 36. In a similar way, p raised to power 6 plus q raised to power 6 will also be one of the factors for this p raised to power 36 minus q raised to power 36. But p raised to power 12 plus q raised to power 12 and p raised to power 4 plus q raised to power 4 won't be the factor for p raised to power 36 minus q raised to power 36, because p raised to power 36 minus q raised to power 36 can be written as p raised to power 12 to the power 3 minus q raised to power 12 to the power 3. And here the power is odd, so it won't have a factor of p raised to power 12 plus q raised to power 12. In a similar way, this can be written as p raised to power 4 to the power 9 minus q raised to power 4 to the power 9. And again, here the power is odd, so it won't have a factor p raised to power 4 plus q raised to power 4. So except C and D, all the other four would be the factors of p raised to power 36 minus q raised to power 36. Now, let us see this question. What is the remainder when 31 raised to power 93 plus 32 raised to power 93 plus 33 raised to power 93 is divided by 64? We know a raised to power n plus b raised to power n has a factor of a plus b only when n is odd. So let us try to use it to find the remainder when this number is divided by 64. Well, to find the remainder, let us combine the first number and the third number. So 31 raised to power 93 plus 33 raised to power 93 is of the form of a raised to power n plus b raised to power n. And here the power is odd. So we can say that it will have a factor of a plus b, that is a factor of 31 plus 33, which is 64. So we can say that the summation of the first number and the third number will have a multiple of 64. Also, from the second number, that is 32 raised to power 93, we can say that this contains 32 93 times. So that means it contains a multiple of 32 and 2, that is a multiple of 64. So that means the summation of the first and the third number contains a multiple of 64, and the second number also contains a multiple of 64. So we can say that the whole number will contain a multiple of 64. So when this number would be divided by 64, there won't be any remainder. So the remainder would be 0. So you can see how simply by knowing the factors of a raised to power n plus b raised to power n or a raised to power n minus b raised to power n, we can solve these questions very easily. So that's why knowing these concepts becomes very important. So that's it for today's video, in which we have seen some problems based on algebraic formulas and problems based on numbers which are in the form of a raised to power n plus minus b raised to power n. But I would request you to practice some more questions, because the more you practice, the more you learn. I hope you have learned something in today's video, but if you have any confusion, you can watch the video again, and still if you have any doubts, you can put it in the comment box. I will try to answer each one of your queries. So if you like my videos, then do subscribe my channel and also share with your friends. I will see you all in my next video. Till then, keep learning, keep sharing, and keep growing. Thank you.